In this segment, I'll be showing you the use of an Excel spreadsheet called ANOVA Example 1 that should be in your course handout. And using this spreadsheet, we will essentially do the same calculation that I've showed you the results of in my lecture slides. If you open this spreadsheet, you will see under columns A through F, from rows 1 through 6, the original measurements that were obtained on 6 workers. The 6 workers are referred to here by lowercase a, b, c, d, e, f. And each worker has 5 measurements made on him or her. So for example, for worker lowercase a, we have 5 measurements in column A, rows 2, 3, 4, 5, and 6. So the first data point is 1.36, 3.67, and so on. If you now look further down in columns A through F, starting at row 9 and ending at row 14, we show the log transformed values of the same measurements. So 0.31, which is in column A, row 10, is the log transformation of 1.36, which is in column A, row 2, and so on and so forth. Thus, we now have a set of 30 log transformed values of the exposure. Now, before we can start doing the analysis of variance, you need to do a few things in your Excel environment. And what you will do depends on whether you have a Mac or a PC. I will first demonstrate what you need to do on a Mac, and then we'll talk about what to do on a PC. So in a Mac, when you open up, you will first click on the Tools data at the very top, and then at the bottom of the options, you will have Excel add-ins. And go ahead and click on this option, and a window opens up, and you have an option to click Analysis Toolpak and Solver add-in. Go ahead and click on both of those, and then click OK. And now you come to the lower set of tabs at the bottom, and now click on the Data tab, not the data at the top, but the data in the lower set of tabs. And you will now see on the extreme right at the top 2 new icons called Data Analysis and Solver. Go ahead and click on the Data Analysis tab. And if you now go to the very first option under the Analysis tools, it is called ANOVA single factor. And we'll select this option. And now you have several new options that you'll have to select. And the most important is the input range. And here we need to put in the range of cells that contain our data. And in this case, we are going to work with the log transform data that are in column A, row 10, all the way up to column F, row 14. So we will select this entire data set, and you will see that the input range now selected is column A, row 10, through column F, row 14. And the data are grouped by columns because each worker is a separate column. For example, worker number 1, the lowercase a refers to one worker, B refers to a second worker, and so on. So the data are grouped by columns. And the output range is where you want the results of the ANOVA analysis to appear. And in this case, the spreadsheet here already shows the results of the analysis. But just to demonstrate it, I'm going to create another set also showing the results on the same spreadsheet as the first one. And I'm going to say that the output range, I'll put my cursor there, and I'll put my output range as column P and row 14. So this is where I will want my new results to appear. And if everything goes well, then these new results will match what I have already calculated and I'm already showing on the spreadsheet. Then you click on OK, and now you have the results of the ANOVA that have just been calculated. And let's see if the results that we just calculated matched with my previous analysis. There are a couple of things you will notice right off the bat. In our new analysis, the results are shown as column 1, 2, 3, 4, 5, 6. In my previous results, I'm actually showing the name of the worker, a lowercase a, b, c, d, e, f. I also previously had rounded off the sums and the averages to 4 digits, whereas the new one is not doing any rounding off. But all the results are exactly the same otherwise. So this is the way in which the analysis of variance for a single factor is carried out using an Excel spreadsheet. Now, when you use this spreadsheet for data sets other than this example data set, there are other things also that can be calculated. So if you notice under column D, row 27 through column D, row 31, there are some useful values that are being calculated in this spreadsheet. And if you click on column D, row 27, this is the between worker variance, and it uses a formula. If you look up at the very top where the formula line is, it is calculating the difference of cells K24 and K25 and dividing it by 5. And so these are K24 and K25 are the results of the ANOVA analysis. And they are basically the mean sum of squares for the between worker and within worker variances. If we now go to column D, row 28, this cell is the calculation for the total variance, and it is the sum of cell D27 and K25. So we calculate that using the formula at the top. Likewise, if you go to column D, row 29, it is calculating the ratio of the between worker variance to total variance. And if you recall from my slides in the lecture, the between worker variation was around 27% of the total variance. Then we go to column D, row 30, and this is the within worker geometric standard deviation. And again, the formula is shown at the top, and we calculate it as 1.63. And then finally, we come to column D, row 31, which is the between worker geometric standard deviation, and this is calculated as 1.35. What I would recommend to anyone using this spreadsheet is that they understand the formulas and which cells in the ANOVA output are being used in the formulas and change the spreadsheet accordingly for their needs. So for example, if you have a much larger data set than this example, then you may want to use the formulas for the appropriate cells in the spreadsheet once you know where the ANOVA output is being displayed. And the same thing if you have a much smaller data set. One caveat for using this spreadsheet is that it is applicable only to what are known as balanced data sets, meaning that each worker, in this case, has the same number of data points. If you have unbalanced data sets, meaning that the workers have different numbers of measurements, then this approach will not work, and the ANOVA program actually will not work properly. So that is one limitation of this Excel-based program. If you want to do unbalanced ANOVA, then you are better off using more sophisticated software such as SAS or Systat or something of that nature. Now I'm going to talk you through how to install ANOVA if you have a PC with Windows. So again, you open up your Excel spreadsheet, and first you would go to the top tab, which is called on File, and then at the bottom of it, you'll see a button called Options. So click on that button, and a window will open up with several options on the left hand, and you go to the option which is the second from the bottom called Add Ends. Click on that button, and you will see several options for Add Ends. I would like you to pick the Analysis Tool Pack option and click OK. And once that is done, if you exit the File option and come to the main Excel spreadsheet, and at the very top, you'll see under the various tabs, the tab called Data. On the top right-hand corner, you'll see an icon called Data Analysis. Click on this icon, and a window will open up, and this window is identical to what I showed you when I was demonstrating the ANOVA spreadsheet on a Macintosh. From this point on, everything is identical to what we have discussed previously.